Bitwise. Today we will see the problem number 3314, which is to construct the minimum bitwise array 1. So let's see what we have given in this question. So you are given the array nums consisting of n prime integers. Okay, so we have given the array with the prime integers. You need to construct the array answer of length n such that for each index I, the bitwise OR of nums of I, answer of I, and the answer of I plus 1 is equal to nums of I. So this number plus 1 उन दोनों का OR. Okay, so we have to calculate the OR of answer of I plus answer of I and the answer of I plus 1. So their OR should be this one, nums of I. Okay, so here that is given to us for simplifying this, that answer of I OR means XOR, not a XOR. This is only bitwise OR operation. Answer of I plus 1 equal to nums of I. Okay, so we have to form this type of array, answer array. Okay, additionally you must minimize each value of answer of I in the resulting array. So we have to minimize this array, minimize every single element of this array. Okay, if it is not possible to find such a value for answer of I that satisfies the condition, then set answer of I is equal to minus 1. Okay, so here in this for 2 it will be not be possible to find that answer of I, so that's why here we have written with the minus 1. Okay, let's see the examples, what the examples are saying. Okay, I will just copy this also, second example. Okay, now let's see what the examples are saying. Okay, just take this one first. Okay, so in this now 2, 3, 5 and 7 are given to us. Okay, 2, 3, 5 and 7 are given to us. Output is minus 1, 1, 4 and 3. So let's say for 2 its binary representation will be this. Okay, now we have to make such a that answer of I, by which answer of I plus answer of I plus of 1. Okay, answer of I plus of 1 should be, this will be the OR bitwise OR. Okay, so this should be 2. Okay, but now in the binary representation, let's see the second example how we got the answer of 3 as a 1. So this is the binary representation for 1. Okay, I will make it. Okay, yes, this is the binary representation for 3. Okay, for 3 it will be 1, 1. Now to 3, to minimize the answer of I, we can take 1. Okay, now how we will take this 1? Why we will take this? Because we have to cancel out this, because when we add the let's say we have this number. Okay, we have this number. Now by adding 1 to it, okay, the binary representation for 1 will be also this 1 only. Okay, so adding to 1 to this will be result to this 1. Okay, so all we have to play with the least significant bit. Okay, the least significant bit, we have to play with the least significant bit only. So now we can conclude that if in the 2, now in 2 this is a prime number, but it is also the even prime number. This is the even prime number, so this doesn't have this LSB as a set bit. So that's why this cannot be possible to make the answer of I. Okay, the answer array, so we cannot make this make its answer. Okay, this cannot be possible when we have the LSB as unset bit. Okay, now now if we have the LSB as set bit, so what we will do, let's see the this is the observation play. Okay, let's observe this 5 and 7. Okay, so 5 bit representation of the 5 will be, okay, just I will erase this one. Okay, so the bit in bit representation of the 5 is this 4 and this is the 5. Okay, for 5, and 5 for 7 it will be this. Okay, okay, now we have 4 and 3, so we have 4 here answer, the 4 representation. Okay, the bit representation, binary representation of the 4 will be this. Okay, now the binary representation for 3 will be this and this. Okay, now how we have done this? Okay, how we have done this? So we have only to get the last MSB, last LSB. Okay, last least significant bit. We can traverse from right to left. So if we have this bit as a set bit, so we will count it. Okay, if we doesn't have this bit as a set bit, so we will break the loop. Okay, we will not go ahead. Okay, if we have this as a set bit, okay, so we will convert it to 100. Okay, we will convert the last least significant bit to 0. Okay, here also we have 1 1 1, so we will convert it to okay, we will convert this last set bit, the last continuous set bit, to 0, because why we are doing this, just imagine that when we add any of the 1 to any of the number. Okay, so just we have this 1. Okay, this is a binary representation of any of the number. Okay, binary representation of any of the number. So when we add 1 to it, so what we get, this will be 0, this will be 0, this will be 0. Okay, sorry, 0 0 0 and 1. Okay, so this will be we are getting. Okay, so now this is the similar we have to do here. Okay, when we have, okay, we got this. Okay, now to get this answer, this as an answer, so we can do, to get that as an answer, so we can do, okay, we can do as, to get this as an answer, so we can do like this 1. Okay, 1. Okay, here how many ones are there? 3 and 2. Okay, 3 and 2 ones are there, means 5 ones, so we will get 4 ones here. Okay, 3 and 4 ones plus 4 ones plus 1. Okay, sorry, this is the OR. Okay, bitwise OR this, so we will get 1 2 3 4 5 as ones. Okay, because here 1 1 1 1 we got. Okay, but bitwise OR of this, so by calculating this, we will get this 1 is there, so we get 0 0 0, all will be zeros. Okay, yes, this we will get. Now by getting the OR of this, okay, so let's do this 1 1 1 1. Okay, after getting the OR, we will get this. Okay, so that's why we are neglecting the continuous OR. Okay, continuous set bit. Okay, continuous most significant bit. Okay, let's take this second examples also. Okay, let's see these examples also. So here in 11, for 11 we have this okay, sorry, this as a okay. So this is the binary representation for 11, and okay, its answer we have got as a 9. Why? Because we have removed this set bit as okay, we have changed that set bit to unset bit. Okay, so this binary representation can be represented as a 9. Okay, now for 13 we have this okay, this we have. Now for this we have the 12. Okay, 12 as answer. So which bit we have set to 0? This bit. Okay, this bit we have changed it to unset bit. Okay, so for unsetting this bit we can use the bitwise XOR operator. Okay, the XOR operation we can do by for changing that particular bit. Okay, let's see that for okay, now let's see that our solution, what the solution our is. Firstly we will create the answer array where we are storing the answer. Then we have nums dot okay, so we have only initialized that nums dot size. Then we have then we have this okay, then we have this n for loop. Okay, for getting the answers. Okay, now if so in place of this, if nums of I is not is modulo equal to 2 means we are checking that if it is even, so then we will push back directly -1. But we have given here that all the numbers are consisting of the prime integers. Okay, so there is only the one number which is a prime and also the even prime number. So the even prime number is only 2. So if in this place we have only written just like if nums of I equal to 2, so we can do okay, so this will also be submitted here. Okay, if it is equal to 2, so this can also be submitted there. Okay, then if it is not the 2, so then we will find out the last LSB. So last continuously we will traverse from the right hand side, okay, of the binary representation. Then we will calculate if any of the number is unset. Okay, if any of the bit is unset bit, so then we will break. Okay, otherwise if all the numbers means just like in this representation, okay, in this representation, so this is also set bit, this is also set bit, this is also set bit, so the final jth value will be this. Okay, this will be the jth value. Okay, this will be the jth index. Okay, jth value. So in this way we will then if we have this as a 0, so we will break here. Okay, and after that we will change that 0 just like this saw. Okay, if we have this 1 so after completing this all the for loop for the all the bits, after completing that we will change this bit. Okay, we will change this last last LSB to 0. Okay, we will change by using the XOR operation. Okay, and then we will push back it to the our answer array. Okay, so this will be changed to 1 0 0 0 1. Okay, this will be changed to this. Okay, now if we are adding it to the 1, so 1 we will get 1 0 1 0 0 1 and 0. Okay, now we have to XOR this. Sorry, we have to make the bitwise OR operation for this 2. Okay, so we will get then 1 0 0 1 1. Okay, so this is our solution. If you are not getting any of the concept, so please comment down below and I will be answering your doubts. So thank you.